So in this video, we're going to show you how to graph using R. This file will show you how to create graphs for both categorical and quantitative data. Before we do that, I want to talk about the head and glimpse command. So first thing I need to do is read in my data frames. So in my setup command here, I have my data frames. I can run those. And I now see all my data frames are showing up over here. So I'd like to look at those data frames. And so there's many data frames that are available for you to read in RStudio. I want you to see the RStudio basics, and there's actually one on how to read data sets in for how best to read them in. The command head and the command glimpse will allow you to see these names of the variables and some of the kind of the structure of the data set. So I can find this out by clicking on the little arrow next to the one I want to look at. You can see the structure of it there and what the variables are we have. I can also click on the name of it and we'll open up the data set here for me to look at. And I can see the whole data set here. I can use the head command of my data set, fab color. And that head command will just create and show you the first 6 rows, shows you the structure of it, shows you that color is a character. I can also use the glimpse command. The glimpse command does this also, just does it in a little bit different format. Shows you this 27 rows, which it shows you over here, this 27 observation. Shows you the 7 columns, and over here it shows you the 7 variables. And again, it shows you a little bit of the structure of them. So let's talk about categorical plots and how we do categorical plots. So we have a bar plot is the first categorical plot I'm going to use. To create a bar graph plot, we're going to use GF_bar. Now, GF stands for graph function. Underscore is there because I'd like a space to make it more readable. This command is used in a package called Mosaic. And I just want to show you, we read in the Mosaic library right here. So that's the library we're using is Mosaic. There are other libraries you can use to create graphs. This is just the one we're using. And that always starts with GF for graph function whenever we're doing any plots in this. Then you're going to get a parenthesis. Kind of this is my function. And I have function notation. So my function with parenthesis. I start usually with a response variable and then tilde my explanatory variable. Bar graphs will only have explanatory variables, so there won't be a response variable. Even though there's not one there, you still want to start with it. And the tilde kind of means and then. So I'm going to tilde and then here's my variable. I can have lots of variable data sets over here, data frames. So we're going to use data equals data frame to tell it which data frame I want to work with. The ... means that there's other things I can in fact see and do. All bar graphs are created with the same command. Again, that ... means there's other options we can do. You're going to replace wherever you see variable, you're going to replace it with the name of the variable you're working with. In fab color, we're dealing with color. Instead of data frame, you're going to type in the name of the data frame from over here. So always replace those names whenever you see those. All right. So we're going to use a GF_bar. That again is my command I'm using to create a bar graph. The parenthesis again means this is my function. Again, I start with a tilde and then my variable of color. And my data frame is data equals fab color. So this is what this looks like. That's a basic graph. And that's perfect. If that's as far as you can get, that is your basic graph you can have. And that's as good as it is sometimes, and that's all we definitely need to get. Sometimes, though, you'd like to have a title. Titles are better to have. Sometimes instead of count, I'd like to know what this count is related to. I'd like to have a better title down here on my x-axis. I might also want to have some color. So this command, it gives my basic, but we can do some other things, and that's what that ... is about. If I want a title, we would do title equals, and then you would type in quotes, whatever title you want to have. Make that title be something that makes sense to the reader so the reader knows what the graph represents. Don't say bar graph because they already can tell it's bar graph by looking at it. So you want something that describes what those bars represent. Then you want the label. Your X label could be whatever you want that label to be, something that gives you a little bit more wording than color. Um, Again, Y label, the axis on the Y, the label on the Y axis would be Y lab. And again, in quotes, whatever you want it to be. You can do color. You can do color. Color actually just outlines the bars. Um, so sometimes we use color depending on if we just want to make a dot something, a different color. Fill is if you want to fill things in. So I would like to fill in those bars. And again, in quotes, you type in whatever color you want those bars to be. All right, so this is the following graph that was created with all those. So here again, I've got a GF bar. I've got delta color. I've got my data is fad color. I've got my title is my favorite color of CCC statistics students. I happen to know what that data set is. My X label, my X lab is the favorite color. My Y lab is the number of students. And then I want to fill it with the color blue. Then I run this command and there is my nice graph. You can see the nice title up here. If you don't like that title, you can change it and it'll change it for you. Here's a much better thing than just count. It tells you what the count is representing as number of students. There were 8 students who liked the color blue, 6 who liked green, 1 who likes orange, and so forth. And I see favorite color down here, and my bars are all nice colored blue. If you don't like the color blue, pick a different color. There are lots of colors you can pick. Just Google RStudio colors, and it'll come with all the different colors you can pick. Another graph is a dot plot. Dot plot is kind of the exact same way, except you use GF underscore dot plot instead of bar. Again, everything can be exactly the same. I left off the X lab, so let's go ahead and put that in. So here I'm going to type in X lab equals, and I might put in things like favorite color. And then I might do Y lab equals, and I might type in something like number of students. Notice I have a comma in between each one of these different pieces that kind of separates your list. And then I can run this again. And there's my dot plot. I did a title of just favorite color. If you don't like that title, you can actually change that. And notice when I run this now, that will change it for that. Okay. I don't particularly like dot plots, so I don't suggest them. Quantitative data, another way to do this is a histogram. Again, same idea, you use GF underscore histogram. Again, graph function underscore histogram, because that's the one you want to do. And then everything's kind of the same way. Again, I got GF underscore histogram. I'm going to use my recurrence one. Come over here, I can see my variable name is tumor. Make sure you type it exactly as it sees. If it is case sensitive, make sure it's not capital. Make sure it's spelled the same way. Data equals recurrence, and my title is recurrence of tumors after chemotherapy. My X label, my Y label, and my fill. And there's my histogram. A density plot is another type of graph. It basically smooths off a histogram. It also doesn't depend on the size or the width of the interval. The bin width will actually affect what the histogram looks like. Density plot doesn't exactly do that. So we can run this one. Again, same idea, GF underscore density, tumor, everything's exactly the same. In fact, you can copy and paste everything in there. That's not changing. And now you can see you've got kind of 2 little bumps here, and that's what the graph looks like. This Y label, I didn't change it to anything. It's just called density. It's kind of telling you how you can think of it as how many values were thrown into that section. kind of represent under there. So that's why it's called density. A dot plot is another way you can do this. Again, I don't particularly like dot plots, but you can do this. In this dot plot, I get the dot plot of my tumor. My date is recurrence, my title, my X lab, my Y lab. And then I did a bin width. This is where I wanted to change that to be a different size. When I run this, it changes that bin width to be a different size. If I had that be 1, to show you what the changes are, this, run this one, and now they're much smaller. If I went to 10, run that, and now the dots are much bigger. That's up to you of what size you want. Accessing data sets, there's lots of different ways to do that. We're using the Mosaic package, but there are other packages you can use, and there's other things we can do. There's also a way how you type the data frame is also important. Before you finish out, you can also do a piping symbol. A piping symbol is this graded vertical line and a greater than symbol, or percent greater than percent. They're called piping symbols. They link lines together. This allows you to use the first line and the second line. It also allows you to create different types of graphs you want. And it also allows you to kind of maybe put graphs together. It's also another way you can use it to kind of get different ways to do data frame names. So instead of doing data equals data frame, you can actually use data frame and then a $ and the name of the variable. And that just basically says use this data frame and then use this variable in that data frame. That $ says this is the variable name. In the command line, you use that instead. So I like the data equals data frame, but there are other reasons to use the other one. If you want to overlap two graphs together, you can actually do this on the same thing by using the piping symbol. So the end of the first line, you'd put this piping symbol and then put the new line. So you've got your GF density, tumor, all this information. And then I'm going to do GF underscore histogram, again, tumor, again, this data set. I want a different fill for it. Notice this one I filled with green and this one I'm going to fill with blue, but I don't need to put the title and all that. It will actually just use the title from the first one. So now I can see kind of how my density plot and my histogram are kind of related to each other. So that's a nice feature where you can put them on with each other. You can also facet for a qualitative variable or categorical variable. This basically faceting means it separates this data frame for a particular value of this qualitative or categorical variable. If you want to look at a density plot for a categorical variable based on that data for the quantitative variable, based on that categorical variable values, you can do that. So in this next example, we're going to show you how to do that. You can do GF underscore density. You can do that categorical, that quantitative variable. Don't know what I was doing. So you do need a density plot on a quantitative variable. And then you do a vertical line and you put that categorical or qualitative variable after that. And then data equals data frame. You can also do it by doing a fill with that. So a fill will also do that. So the main thing to note is that between that quantitative variable and that categorical variable is that vertical line. And it's just that vertical line on your computer, on your keyboard. So here's an example that does this. We're going to do GF density. We'll do a survival. So inside of our cancer data set, we have the variable survival. And then we're going to do a vertical line of organ, which organ it was. And then the data equals the cancer, and then all these different pieces. I'm going to run this one first. So if I just am on this line, I can do command return or control shift, control enter. And notice it divides it up, it facets it up, it separates it based off of which kind of cancer we're dealing with. Breast cancer, lung cancer, colon cancer, ovarian cancer, or stomach cancer. And it just graphs up for those pieces. I can also do it the other way where I have the fill. So I'll do that one, run that one separately. And here it puts them together, but it does colors for them. So you can kind of see how they relate together. If you want to run both at the same time, you can run both, and then it will create both of them for you. You can just go back and forth between them. So that's just a way to facet. One more type of graph that we use on quantitative variables. Separated by a categorical variable. Is this jitter command. So GF underscore jitter. It takes that quantitative variable and then it facets it based on that categorical. And this is actually one where it is response variable and explanatory variable. So it is dividing it that way. So jitter plot does have a response variable of my survival, an explanatory variable of my organ, and then my data set and so forth. Notice that structure is always the same. I'm going to run this one. And what it does is it takes each one of these breast cancer and it kind of does a dot plot, but instead of putting the dots all on top of each other, it kind of separates them out a little bit. It kind of shakes them a little bit and moves them off of that main line. So you can kind of see a little bit more information. You can see how many are in this breast at this level of survival and how many are up here. You can see that a little bit more detail with this because you can now separate them out by that. The last thing I want to mention is filtering. We can create a new data set that is filtered for a particular quantitative or categorical, so qualitative or categorical variable. That means that you have a data frame that only contains some of the units of observation in the original data frame. To do this, you can create a new data frame. You can also do the original data frame, but that means you've changed that new data frame, and you might want to have a new one. So you'd have your name of new data frame. And you wouldn't call it new data frame. You'd give it a name that makes sense. Then again, the assigning arrow. Then you do whatever the name of the data frame you want to take it from. And then, so there's your piping symbol. You're going to filter it. Your variable is going to equal, and it's equal because we can do not equal to, we can do less than or equal to, we do greater than or equal to. So this is the way we show we want it to actually equal whatever that value is. So as an example, in using the data, a data frame cancer, you want to filter for breast cancer, then it would be breast. And then you have your cancer, your data set cancer. And then, so here's the symbol that says assigned to this. And then is your piping symbol. I want to filter, I want organ to be exactly equal to breast. I can run that. It doesn't look like anything happened, but I now notice I have a data set over here called breast. If I open that one up, I can see it only contains breast cancer as the organ. You can do all the commands that we just did on this new data frame. Just make sure you use the data frame of breast instead of that. This is another way to also facet, but this only gives you for that one variable. So if you're going to facet and want to look at all of the variables, it's better not to filter and just use the faceting, but this is available. And then we can do a scatter plot. To create a scatter plot, this is where we are going to have response variable or and we're going to have an explanatory variables. So you're going to have the same idea. You're going to create this scatter plot. A scatter plot is just a bunch of points all over the place. So it's a point plot. So that's why it's GF underscore point. We're going to do temperature. So we're using the data frame elevation, which has temperature and elevation. I'm going to have temperature, tilde, elevation. We think temperature is responding to what elevation you happen to be at, and your data is equal to elevation. Again, same thing, title equals, xlab equals, and so forth. And there is my scatter plot that shows that, and you can look at for the relationship you think exists there. It looks like a negative linear to me. You can also do a time series plot. A time series plot is where your independent variable or your explanatory variable is time. So again, it's still going to be response variable and explanatory variable. Same thing is happening here. It's just your explanatory variable or independent variable is always time. So make sure you always put the time after the tilde, whatever the time variable is you're working with. And everything else is exactly the same. So once you've learned that in one command, it's always going to be the same in all these other commands. So we're going to look at this data set called dates. I can do the head command to look at this. And here it is looking what it is. I've got my time column in here. I can't use the Monday, Tuesday, Wednesday, Thursday, Friday. That won't work as well. So I'm going to use this time column instead. And I'm going to look at the number of rooms. So this is the number of rooms that are being rented on this particular day. So rooms is my response variable, tilde is my tilde, and then my predictor variable is time, and my data is equal to dates. And again, everything's exactly the same. And there's a time series graph. It's using GF line because it actually connects the dots up. We can do this with a time graph because it makes sense to go from one to the next. There's a reason to connect these dots together. Scatter plots, there's no reason to connect these dots together. So we don't do a line graph on these. But with time series, there is a reason to connect them together. You can also change the limits on your axis. You can, if you don't like the limits it gave you, you can change them to Y limit. It's changing the Y-axis. C combines these together, and then you give your lower Y value, comma, your upper Y value. Similarly, you can change them on the X-axis.